Let's recap what we have achieved in the previous videos. So in the previous video, we started by a file called the abstract user interface specification file, where we have a system called bank. And also we got 4 events: new, deposit, withdraw, and transfer for the commands or user initiated events for the banking system. And then using this file, we generate using the ETF a starter project with lots of classes. And then we open that in the iFlow Studio and show you how it can run between the GUI mode by default. And also we show you how you can change it. For example, go under the root class over here, and then we change the default ETF GUI show history mode into ETF command line show history, which is what we will stick to for this video over here. Okay, let's assume you have done that already. And then we show you specifically how you can use in the command line the difference between interactive mode, where you simply type by keyboard, and also the batch mode. And for the batch mode, we created an acceptance test case like this. So this for this particular acceptance test case, we create a new account called ID1, create another account called new ID2, and also we deposit into this particular ID1 account $234. That's what we have achieved from before. So now let's try to understand a little bit more about the structure of the generated code. We don't have to understand exactly all the details, but I'll show you just enough so you can continue with your developments for the banking system. Okay, what I want to show you, first of all, let's go to iFlow Studio over here, and notice that we got at the top, we got 3 clusters. We have already seen the root class. Basically, you only go to the root class to change the mode of the switch between command line or GUI, or adding some ES tests over here. And then also we got a cluster called generated code. Usually you don't have to worry about the generated code unless you're told to do so. Okay, let's only look at the bank cluster over here. Under the bank cluster, we got abstract UI. So this is the cluster containing all the user command classes, which I will go there in just a moment. And also we got one for the GUI, which controls how we launch the default GUI mode. And this model here, this is where you have to put lots of effort into. So this is where this is the model cluster storing all your business logic. By default, we simply just give you ETF model, which is a normal class, reference class. And also we got, you can see the icons a little bit different, a little bit more like a rectangle shape. ETF model access, so this is the expanded class. So this implements a singleton pattern as we learned in the class. So basically we want to have only a single instance of the ETF model to be shared among the inputs, outputs, and also all the relevant suppliers, all the relevant clients. So now that's why we are applying the singleton pattern over here. There's only a single instance to be manipulated for the ETF model. Of course, later on, we're going to change the ETF model to be something else. Okay, and then we also got the output cluster over here, and typically you don't have to worry about the output cluster. Okay, so now let's have a look at inside abstract UI over here. We have a cluster called user commands, under which we got these classes. We got ETF command. You can see the icon here tells you it is deferred, which means it is abstract. There's no, it's not possible to create an object directly from ETF command, under which we got 4 descendant classes. You can see ETF deposit, ETF new, ETF transfer, and ETF withdraw. So these are the 4 classes. You can see over here, I say ETF withdraw, for example, inherits ETF withdraw interface, which is some class in the generated code cluster, which you don't have to worry about. And the ETF withdraw interface inherits from the ETF command. That's why I put the ETF command over here. Okay, if you look at the ETF command class, notice one thing here, which is really important. We declare the model attributes over here of type ETF model. So there's a client-supply relation over here. So ETF command is a client of ETF model. Okay, we're going to show you the architecture diagram in just a moment. And then you can see, since all these 4 classes, all these 4 effective classes, deposit, withdraw, transfer, and withdraw, they are all descendant classes of ETF command. They're going to inherit these attributes for sure. And then notice that how we actually get access to the model. Okay, you can see the model, the way we do it is by, in the constructor for every command, we're simply going to declare a local variable model access of type ETF model access. As we learned about in the singleton pattern, the way we get a reference to the ETF model is not by directly instantiating ETF model. In fact, we are not allowed to, because for ETF model, you can see the only class that is allowed to create an instance for ETF model is ETF model access. That's exactly how the singleton pattern is supposed to work. And then if you go to ETF model access class, you can see we got expanded, and also we got a once routine. So whenever you want to get a reference to the ETF model, you will simply create an ETF model access object and call the M feature on that. And that will give you a reference for ETF model. And remember the once and also the invariants that we learned in the class. Okay, so the generated code for the ETF starter projects is basically part of it is an instance of the singleton pattern. Okay. Let's go back here and look at ETF command once more. You can see the way we declare is like this. Because it's expanded, so we don't have to explicitly create the instance for expanded type. And then we simply say model, which is of type ETF model, is assigned to model access, which is the expanded object over here, .m. So this is the only way to get a reference, singleton reference for the ETF model. Okay, so hopefully that's clear to you. Okay, that's about the model and model access. Let's now summarize by using an architectural diagram, and then to give you an idea later on how you can modify things so that things might start working towards your expectation. Let's now switch to iPad, and now I want to show you this architectural diagram. We have already seen the code already, but why don't I just review everything again. So first of all, we have basically so these, of course, are not all the classes for your generated code, but these are the important ones that you should know, at least for now. So we have two clusters. We got a user commands cluster, and also we got a model cluster. Okay, for the user, so these are the clusters that you're most likely to modify. Okay, for your projects. And as we said before, we have a ancestor class over here called ETF command. Okay, the ETF command actually declare an attribute, which means ETF command is a client of the ETF model class, right? Remember this line, the green highlight I just made over here, ETF model is a client of ETF, ETF command is a client of ETF model using the attribute model, using the feature model. But how do we see this? Again, back in the code, if you see ETF command, the declaration over here. So this line over here, model of type ETF model, in the context of ETF command corresponds to this client-supply relation over here. Okay, and also you can see each one of the effective command classes over here. Again, you can see that this is deferred, which means it is abstract, and all the descending classes are simply effective, which means you can create instances out of them. Okay, so now let's have a look. And we have over here ETF new, ETF deposit, ETF withdraw, and ETF transfer. They all inherit this model attributes from their ancestor class ETF command. Okay, and then so that means they can all share the same instance of the ETF model objects. Okay, so now let's have a look at the model side. Oh, one more thing. Remember, we also showed that over here. The way we get access to the model is by declaring model access of type ETF model access, which is expanded type. So this corresponds to over here, this line over here. Let me draw a different color. What about just purple? Okay, and then so this one here, ETF command is a client of ETF model access of type of the feature model access that corresponds to this local variable declaration over here, model access of type ETF model access. Okay, so far so good. And then one more thing to show, we can see under the model cluster over here, so we have the ETF model and also ETF model access, who is the client and who is the supplier. Okay, you can see that from the ETF model access class, under the model cluster over here, we declare N, which is a feature once routine of type ETF model. That means ETF model access is the client and ETF model is the supplier. Okay, so that means you can see over here, let me just circle that. So ETF model access is the clients, and then over here ETF model is the supplier. Okay, and it's of feature M. Okay, so that's basically all the relationship you should know in order to make some changes. So the idea about making changes is as follows. Basically, whenever you want to change something on your model side, you want to change the behavior of the external program, you should always do something about the ETF model over here. Of course, ETF model is only a single class by default. Later on, this ETF model can be replaced by some other class, for example, bank. And then if you want to modify the bank behavior, the external behavior of your program is also going to be modified accordingly. Okay, I will show you that in the later video. But for now, this ETF model is the class to change in order to see any external changes on your program. Okay, and one thing to show you more. For each of these classes, as we know, they are also the clients of the ETF model, as we learned. Let's see exactly how they make use of it by calling some feature, basically. So now if you go to, for example, ETF deposit, you can see we do have the model feature over here. You can see the model here. Okay, and model, remember, it was declared in the superclass called ETF command, and you can see model is declared over here. Okay, so let's go back to ETF deposit. You can see we simply model dot default updates. So by default, this is the only feature that's available for calling to be called in the ETF model. Let's go to ETF model over here. You can see default creates. Default updates is the only one that we can call. You can see, not to be too surprising, for default updates, every time you call that, we simply just update some integer counter. That's why you see from the previous tutorial video, we go from 0 initially to 1, to 2, to 3, and then to 4, etc. Okay, so we do have an integer attribute just for illustration by default. Okay, let's go back here, and then this last line over here, we wouldn't talk about it in detail for this video, but just make sure you always keep this line in your deposit or any ETF command as a last line. Basically, what this last line does is publish the change the latest version of the model. Basically, it's something called subscribe and publish pattern that we will cover later in the course. But for now, you just make sure you leave that line alone as is. Don't delete that, okay? Before that line, all you gotta do is, for each command, basically the user, for the external user, let's think about the flow conceptually. The external user is going to initiate a command, let's call new, or deposit, let's say deposit. If the external user initiates a external deposit events, what that would do is ETF abstract user interface framework is going to in turn cause this method over here. It's going to call this deposit command, okay? And the deposit command belongs to the user commands package or cluster over here. And the ETF deposit is going to go through the client-supplier relation of the model and call the relevant model updates operations on the ETF model side. That's what's going to happen. Okay, so we have a separation of concern. When the user first initiates any command, so when the user actually initiates any command, for example, deposit, in turn, it's going to call the ETF deposit. And the ETF deposit is going to, in turn, call the relevant features on the model, for example, model.deposit or model.default updates on the ETF model class. Okay, that's exactly what happened. Okay, and every time we call default updates over here, it's going to increment the value by 1. Okay, as we can see over here. Okay, so that's about the relation between each command classes and also the model class. So now let's just make some simple changes to see how the external behavior of the program might change. Okay, let's do the following. What I would do is, and also you can see that the out feature is very important. The out is like the toString method in Java. So every time the out feature basically is going to output the current states of the model. So how exactly the output format should look like depends on your requirements. I would say in this case, we simply say we're just going to say system states default model state, and then a value for the counter. Okay, we can easily change that. As soon as you change the formats for this out feature, the external output for your program also is going to change. We're going to see exactly how that's going to happen. Okay, let's do something just for fun. So now let's say every time when you try to update your every time when you try to call the default updates from either ETF, deposit, new, transfer, withdraw, rather than incrementing by 1, I want to increment by 2. Okay, I just made a change in the model side, and also the initial value should be, rather than 0, is going to be 1. So what does that mean? That means what we used to see like a 0, 1, 2, 3, 4 is going to be 1, 3, 5, 7, and etc. Let's see exactly how that's going to work. So I compile my project, so everything's compiled. What I would do is I'll go to my command prompt, since now I'm in the command line mode. And then I will go into the test over here, and then I'll go to acceptance, and then instructor. Okay, so I do have the at01.txt. Let me just open that. And it looks like this, new, and also new, and then deposit. So now the behavior would change slightly. Rather than default state starting to be counter 0 is going to be counter 1. After this, rather than being incremented by 1, it's going to be incremented by 2. Okay, let's see exactly that's the case. So what I would do is I would say dot 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 ifgens bank w code, and then bank. I would say -b and then at01.txt. If I do that, you can see exactly the case, right? I got 1 over here, I got 3 here, I got 5 here, I got 7 here. Okay, basically what I have changed was, if you see the diagram, I simply modified this ETF model class, especially the way the state is going to be updated. Okay, that's what I modified. And then since ETF new, ETF deposit, withdraw, and transfer call the same default update feature, so they're just going to update accordingly. Okay. One more thing I want to show you. I want to show you different changes you might make so you can get a feel. Let me also go to, for example, the out feature. So now I want to say, rather than displaying system states, what about I simply say state of bank, for example. Okay, state of bank, and then I will simply say 1. Okay, rather than being so wordy. So I can just go to the ETF model class and modify the out feature. I can say state of bank, and then I will simply just get rid of the rest, and then space, and then just integer output over there. Okay, so now let's say rather than round parentheses, I'm going to do square brackets. Okay, and then compile. Okay, and then let's now try to run it again. Okay, run the same acceptance test, but now the model has been modified and recompiled. So what we got is, you can see we got exactly state of bank 1357. Okay, so now let's do a little bit more fun. Okay, what we can do is let's go to the ETF model class. Rather than having just a single feature, why don't we have the feature that may be called by the different commands over here? Okay, from this cluster over here. At the moment, all of them simply called default updates, but we want to call them let them call it a little bit different. Okay, so what I would do is I will simply say let me just call that maybe deposit. Let me just do all of them. Let's say deposit, and then do. I'll say S is assigned to the last command, which is deposit. And then I will also, I is assigned to I plus 2. Okay, I'll do the same for all the others. So I got deposit. I also got withdraw. And here I'm going to say the last command is going to be withdraw. And then I'm going to have also new. Okay, I'll put new here. And finally, I'm going to put transfer. Okay, let me put the transfer over here. Okay, and then S is assigned to transfer. Also, I is assigned to I plus 2. Okay, and then what I would do is I'll get rid of, I will simply comment this out. And as you can predict, if I say compile, nothing's going to compile, because over here you can see all the 4 command classes, transfer, deposit, withdraw, and new. Since they used to call default updates, but default update has been commented out. So so this can give me tell me exactly where I should make the changes accordingly. So double click on this. So this is the transfer class. I can say model dot transfer. Okay, let me do that over here. Compile. I got the next one, which will be in deposit model dot deposit, and then next one model dot withdraw, and also model dot updates. Okay, let me compile. Okay, and then sorry, not model update, model dot new. Okay, and say compile. Everything compile, and then let me do one more thing before we rerun the batch mode. So now what we can do is state of bank. I can say result.append. So now I'm changing the formats again for the out feature. Let's say after result.append, and then I can say s. So basically this is states after the feature has been called. Okay. Initially, s is simply just going to be empty string. Okay, let me make sure that's the case. Yeah, initially it's an empty string, but I can also change s to be s initially just gonna be init, which means initialization after being initialized. Okay, finally compile, and then what I will do is I will simply just rerun it. Okay, you can see over here, this is the states after initialization, this is the states after the new, this is the states after the second new, and this is the state after deposit, right? So you can see the main point about having this these changes demonstrated to you was it's not that daunting to actually work with the ETF. Basically, all you gotta remember is this diagram over here. So we got our ETF model here. This is the one of the main points for changing things over here. That's the model classes. You don't really have to change the way you access the model. Okay. The second point of change would be each of the command classes over here, since they all share the same reference to the model. So all you gotta do is make sure inside these classes over here, you're really calling the right feature in the ETF model. For example, over here, in my latest change, I say ETF new is going to call a new feature in ETF model. ETF deposit is going to call the deposit feature in the ETF model, and etc. Okay, so I would suggest before you move on to the next video, now make sure you understand the relationship between these classes and also that we have mentioned. Make sure you understand the client supplier and also singleton pattern and also the inheritance relations between these two clusters and these classes, and then make sure you are comfortable with the small changes we made to both the ETF model and also to all the command classes. And then we'll try to make some and then we'll try to rename the classes in the next video so we can gradually move towards the back system that we would like to develop.